Gravity's ultimate triumph, an introduction to black holes. Black holes are among the most fascinating objects in the universe. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. Imagine a place where the fabric of space and time is infinitely warped. This is the essence of a black hole. Black holes are not empty spaces, they are incredibly dense objects with immense mass concentrated into an infinitely small point. This point is called a singularity. The singularity is at the very center of a black hole. Surrounding the singularity is an invisible boundary called the event horizon. The event horizon is the point of no return. Once something crosses the event horizon, it can never escape the black hole's gravitational pull. Even though we can't see black holes directly, we know they exist. We can observe their effects on nearby stars and gas. These observations provide strong evidence for the existence of these cosmic behemoths. Stellar demise, the birth of a black hole. Black holes are formed when massive stars die. Stars are giant balls of hot gas held together by their own gravity. Throughout their lives, stars fuse hydrogen into helium in their cores, releasing energy. When a massive star runs out of fuel, it can no longer support itself against its own gravity. The core collapses in on itself, and the outer layers of the star are expelled in a supernova explosion. If the core of the star is massive enough, the collapse continues indefinitely. The gravity becomes so strong that it squeezes the core into an infinitely small point, a singularity. This is how a black hole is born. A cosmic maelstrom, accretion disks, and other black hole features. Black holes are not just invisible points in space, they have distinct features that arise from their intense gravity. One of the most prominent features is the accretion disk. As matter falls towards a black hole, it doesn't fall straight in. Instead, it spirals inward, forming a flattened disk of gas and dust around the black hole. This is the accretion disk. The material in the accretion disk heats up due to friction and emits intense radiation. This radiation is what astronomers observe to detect black holes indirectly. Another interesting feature is the jets of energy that shoot out from the poles of some black holes. These jets are thought to be powered by the black hole's spin and magnetic fields, but their exact mechanisms are still being studied. Section 4. A universe of black holes exploring different types. Black holes come in different sizes. The most common type is stellar mass black holes. These black holes have masses a few times greater than the mass of our Sun. They form from the collapse of massive stars. Supermassive black holes are much larger. They can have millions or even billions of times the mass of the Sun. These behemoths are found at the centers of most galaxies, including our own Milky Way. There is also a class of black holes called intermediate mass black holes. These black holes have masses between those of stellar mass and supermassive black holes. They are not as well understood as the other types. Section 5. Spaghettification, the ultimate fate. What would happen if you fell into a black hole? The answer is not pretty. The gravitational pull of a black hole is not uniform. It's much stronger at the singularity than it is farther away. If you were to fall into a black hole feet first, the gravitational force on your feet would be much stronger than the force on your head. This difference in gravity would stretch your body out in a process called spaghettification. As you get closer to the singularity, the stretching would become more and more extreme, eventually tearing you apart at the atomic level. Needless to say, falling into a black hole is not an experience you would survive.